Here's hopefully a helpful video and a quick video on tips to simplify square roots. I see a lot of people crawling basically to simplify square root problems, or just basically radicals. I'm going to help you walk instead of crawl, hopefully. Okay, so let's review a few things first and some general tips. At the bare minimum, you got to know your perfect squares from 1 through 10. Okay, so like 1 squared is 1, 2 squared is 4, 3 squared is 9, 9 squared is 81, up to 10. Okay, if you know your squares, then you know the square roots. The square root of 100 is 10, square root of 89 is 9, so just the other way around. Yeah, we got to know these from 1 to 10 at a bare minimum. I actually tell my students to memorize 1 through 20. That is more helpful when the numbers get bigger and when you solve quadratics and all that. Okay, so but at the bare minimum, no 1 through 10, please. And then we gotta know these properties, okay? Square root of a times b is square root of a times square root of b. Okay, you can break up the radical into two when the terms are being multiplied to one another, or you can combine them. They're bidirectional, okay? And square root of a times a, which is just square root of a squared. If we simplify that, that is a. The square root cancels out the square essentially there. Okay, we got to know these. All right, I'm going to go through 4 examples using the crawling method, and then I'm going to redo those exact 4 examples using the walking method. Okay, so let's go over them. Square root of 20. Well, we can break up 20 as 2 times 10, yeah? And then 10, we can break it up as 2 times 5. Okay, 2 times 2 is 2 squared. Yeah, and then we can break this up into square root of 2 squared times square root of 5. These are just the properties. And then square root of 2 squared, the square root and the square cancel, so you're left with just 2. So it's 2 root 5. Okay, so the technique here that I see students do is they try to break this down into the simplest factors. They always pick like 2 to begin with because this is even, right? So let's pick 2. Maybe it's 3 if it's odd. They try 3. Something like that. Okay. Square root of 18. Again, they'll think that, oh, 18 is even, so let's try 9 times 2. Okay. And 9 is 3 times 3, which is 3 squared. And then use the property again, break it up. Square root of 3 squared is 3. So 3 root 2. Okay. This is how a lot of students I've seen do it in the beginning. They break it up into the smallest possible factors, like this: 3 times 3 times 2, 2 times 2 times 5. Those are the smallest factors possible. Okay. Some more examples. Square root of 72, it's even. So 2 times what is 72? 36. Okay. 36 is again even. So that's 2 times 18. Okay. So they might skip some steps now once they're comfortable. Oh, 2 times 2, that's the 2 squared like before, which is square root of 2 squared is 2. So they pull that 2 out in front. Okay. And the 18 is 3 times 3 times 2. They might be able to do this in their head. So then this is the 3 squared, and square root of 3 squared is 3. So 3 goes on the outside. And 2 times 3 is 6. So it simplifies to 6 root 2. Okay. Another one, square of 80. Here's another way people do it. Actually, they do this like tree diagram. 80 is 4 times 2. Sorry, 40 times 2. 40 is 20 times 2. 20 is 10 times 2. 10 is 5 times 2. They draw this like tree diagram. Okay. And then there are your smallest factors. 5 times 2 times 2 times 2 times 2. Okay. And then they might start combining. Oh, this is 2 squared here. So a 2 on the outside, like here. Another 2 squared. So 2 on the outside. Sorry, this pair of 2s and this pair of 2s over here. It's another 2 on the outside. Okay. And then yellow through the 5 on the inside of the radical. So 4 root 5. So they might draw this and then they'll jump to this step over here because they see there's a squared over here and a square over here. So just a 2 and a 2 on the outside. One of the 2s and then another one of the 2s. Okay. And then the root 5 still on the inside. Or again, 2 times 40, 2 times 2 times 40. And then this becomes the 2 on the outside. 20 is 2 times 10. 10 is 2 times 5. This becomes another 2 on the outside. So instead of doing this inside the radical, they might draw this like tree diagram. Okay. These are all crawling, okay? To walk, we got to think bigger, in bigger numbers, not always in terms of twos. These happen to all be even numbers that I pick, so twos, maybe threes, okay? And this is why I tell my students to memorize these perfect squares. We got to think bigger. Instead of just thinking twos, maybe let's think of nines and 16s and 25s, okay? 36s, those will help us, okay? So let's revisit some of the examples. 20, instead of 2 times 10, we can think of it, or we can instead do 4 times 5, yeah? And what's square root of 4? That's 2, okay? So we skipped this unnecessary breaking down to 2 times 2 times 5. We can just directly go from 4 times 5 and then use the property square root of 4 times square root of 5. That's 2 root 5, okay? Similarly, square root of 18, they did the right first step, actually, is 9 times 2, but instead of breaking this 9 up into threes, just directly use the property square root of 9 times square root of 2. That is 3 times root 2. Okay, so we got to start thinking in terms of those perfect squares. We want to try to find if one of those perfect squares, like 4 or 9 or 16 or 25, if those are a factor of these numbers here. If they are, then you can jump a lot of steps. For example, square root of 72. We can first do that it's 2 times 36. Oh, look, 36. Is that a perfect square of some number? It is. It is 6 squared, yeah? So it's 6 root 2. This is how we walk instead of crawl. We notice that this is a perfect square, so we immediately simplify from there. No more breaking it down anymore. So 6 root 2. Square root of 80, if we can think that this is 16 times 5 instead of doing 2 times 40, okay? If we can think of that, if we purposefully try to find a factor that's perfect square, so you could, instead of doing 2, I'm going all over the place, sorry. Instead of 2 times 40, you could have, at the bare minimum, did 4 times 10, because that's, sorry, not 4 times 10, 4 times 20, okay? And that would be 2 root 20. You would simplify it to there. And then the 20, you can do 4 times 5. And then you would get the same answer, yeah? Or we can think a little bigger. So that's why, again, I recommend memorizing all this. If we realize this is 16 times 5, which is the 4 times 4 times 5, which I was hinting at not long ago, yeah? This is square root of 16 times square root of 5, which is 4 root 5. Okay, so again, the tip here, the big tip is we got to think if one of the factors is a perfect square instead of breaking it down like this every single time to these like tree diagrams that honestly waste time in my opinion. Think bigger. Let's walk instead of crawl. Try to find factors that are perfect squares, like 36 here, 16 over here. Okay, if you can't do 16 over here, at least do 4, because 4 times 20, and then 4 times 4 times 5. Even that is faster than doing all these twos over here. That's my tip to help you walk instead of crawl. Hopefully this is helpful.